Fine, let's start. So in the last class, okay, we have seen something called as p-value. Agree? So what is p-value? P-value is nothing but it's a probability for the null hypothesis to be true. Okay. So if the p-value is less, okay, so if the p-value is less, what does that mean? We are having less probability to accept the null hypothesis. In other words, we cannot accept the null hypothesis. So we will reject the null hypothesis. So that is as per the statement. Okay. From the representation, I mean the graphical representation also, a small p-value can also be represented as an area. Okay. So in the graph wise, so it's the area. So if the p-value is less, that means you are having a small area, right? So a small area means a small probability. Fine. So in that case also you can reject the null hypothesis. And one more way to remember or connect is you have the mean at the middle of the graph. Okay. So a small p-value means you'll have a small area. Okay. A smaller area will be moving away from the null hypothesis. Fine. So which also means that you cannot accept it. You need to reject it. Okay. So if the p-value is more or the area is more or you are moving towards the null hypothesis, that means you are accepting. Okay, you can accept the null hypothesis. Fine. So I hope this is what we have studied. So any doubts in p-value is?
No, Santosh.
Okay, fine. Okay, so now we will see how you can use p-value, in which scenarios you can use. Okay, so quickly I will show an example. Okay, so over here if you see yeah, so over here we have something called as Shapiro-Wilk test, guys. Okay, so this test is normally used to test if a data is normally distributed or not. Okay, just to test if a data is normally distributed or not. Okay, so for example, over here if you see, I'm creating a data set, okay, with the size of 300. Okay, and I want it to be in normal shape. Okay, that means I'm saying input.random.normal 300. Fine. So that is x. Okay, so now if you see the x, as you can see, it is almost normally distributed. Sorry, I mean these values are normally distributed, but how can I plot it? Dist plot, I think. Or dist plot. How I plotted this, I forgot. PLT. See, sometimes we also forget. Okay, so simple Google it. Plot distribution plot. Okay, so how can we do that? Okay, so distribution plot is in Seaborn, looks like. Okay, sorry, I was taking it from the matplotlib. Okay, so for that we need to do Seaborn as SNB, SNS or SNB. Okay, and SNB dot dist plot of X. Dist plot. Okay, can you see this? So this X, whatever I have created, okay, in the normal distribution format. So these are the values. Okay, and if you draw a distribution plot, it is almost normal distributed. Agree? So that is from the diagram. Okay, but I want to test whether this is normal distributed. We use the use of this Shapiro-Wilk test, okay, which uses p-value. Okay, using the p-value. Fine. So Yeah, how you need to import the Shapiro is yeah, so where I was doing the Shapiro. Just give me a second. I have imported it already. Stats import Shapiro. Oh yeah, Skype stats. Okay, so from Skype dot stats. Okay, you need to import the Shapiro, or I will do it here only. Okay, so over here from Skype dot stats import Shapiro. Okay, and now when you pass, okay, now when you pass your value x to Shapiro, okay, so it is giving you two values. Okay, you can ignore this statistic, but you need to focus on the p value. Okay, so now see guys, as I said, okay, in Shapiro test also, it is a hypothesis testing. Okay, so oh, 1 second, what happened? Karthik has 1 second. Yeah, Karthik, are you good now?
Yeah, Santosh. Yeah.
Okay, so did you miss anything?
No.
Okay, fine. So now we are conducting a Shapiro test, guys. What is the Shapiro test? It is just a hypothesis testing. Okay, hypothesis testing. Okay, it's a Skype model which will help us in the hypothesis testing. The moment when it's hypothesis testing, obviously you'll have two things. What are those? Two.
Alternative.
Yes. So one is null hypothesis and another thing is
alternative hypothesis.
Alternate hypothesis. Okay. So usually in Shapiro test, okay, so null hypothesis will say the given distribution is normal distributed. Okay, the given distribution is normal distributed. Okay, this will say not normal distributed. Okay, alternate will say this is not normal distribution. Okay, these two are hypothesis. Okay, so now we have passing that x value to Shapiro and it is giving you two values. Okay, you see the p value 0.225. Now, usually this is conducted at a significance level of 0.05. Okay, so this is by default case. Okay, so no one will tell you explicitly, but by default, we consider maximum test with a confidence level of, sorry, significant levels of 0.05. Okay, so now if you remember, if our p value, okay, if our p value is less than 0.05, you can reject the null hypothesis. Can you see here? Or else you need to accept it. Why? Because if p value is area and if it is less than, if your significance level 0.05 for p value is less than that, that means you will having a very small area in support of null hypothesis. That means what? You don't have much evidence to support or to accept null hypothesis. So obviously you should reject null hypothesis. But if p value is greater than 0.05, okay, that means it is having little bigger area, so you can accept the null hypothesis. Do you agree, guys, at this point?
Yes, Santosh.
Fine. So now coming to this scenario, over here we have our alpha is 0.05 obviously, but if you see that p value, okay, it is saying 0.225. Okay, so is p, now we have p value, we have alpha. So is p value greater than or less than alpha?
Greater than.
Okay, p value is greater than. So in that case, should we accept or reject?
Accept.
Accept, sir.
Okay, we need to accept it because we are having greater area. Greater area means greater evidence. Greater evidence means you should support or accept the null hypothesis. So that means what? You are accepting this null hypothesis. What is null hypothesis saying? It is saying normal distribution. So you are accepting that and you are rejecting this. Okay. So null hypothesis is normal distribution. And is it normal distribution? Yes, it is actually normal distribution. Agree? It is actually normal distribution curve and you are accepting that. Fine. So with this p-value also, obviously, you can find out whether the given distribution is normal distribution or not. Are you getting this? What we have done, we have just passed the value. So this diagram is for your evidence I am showing. For example, you don't want to see this diagram. Obviously, what you can do, you can just pass the value over here and you can check the value of p. If the p value is less than 0.05, okay, so obviously you need to reject null hypothesis and say, hey, no, the given distribution is not a normal distribution. Okay, if at all, if it is greater than 0.05, you can conveniently conclude that the given distribution is a normal distribution. Okay, is that clear, guys? Any doubts?
No, Santosh. Fine.
Okay, so here one more thing is, so this is a ground truth. What is ground truth? The actual truth is what? This is normal distributed. Okay, why? Because from the diagram also you can clearly see, okay, from this representation also you can clearly see that the graph is normal distributed. Okay, now that is called ground truth, guys. Ground truth means the actual truth. Okay, it is normal distributed. Okay, now what you have done, you have assumed that it is a null hypothesis is the normal distribution. Okay, what is null hypothesis? Null hypothesis is saying it is normal distribution, and alternate hypothesis is saying it is not normal distribution. Okay, now you're accepting this, but in case due to some calculation error, okay, due to some calculation error, if this value is by mistakenly is less than 0.05, okay, so what you're going to do, you're going to reject this and you're going to accept this. Okay, obviously, right? Because if the value is less than 0.05, you will reject the null hypothesis and you will accept this. So in this case, what you have done, you have rejected the true null hypothesis. Agree? Are you getting? As per your hypothesis, yes, you have accepted your alternate hypothesis. That's fine. Okay. But after completing your test, okay, so after, let's say you did not check this diagram before, okay, you have just passed the value of your x, okay, and just in case, assume just in case due to some system error or some reason, so your value was less than 0.05. Okay, so what you will do, you have rejected the null and accepted the alternate. Okay, so as per your statement, that is correct. Okay, so you have accepted the alternate hypothesis, but later you just wanted to check the distribution, so you have plotted this and this looks like a normal distribution. Agree? So in that case, what you have done, you have actually rejected the true null hypothesis. Agree? You have rejected the true null hypothesis. Do you agree? Or shall I repeat? Okay, guys, don't worry. You can ask, guys, that's fine. If you're not getting, that's completely fine. You can ask. See, what I'm saying here is, you have passed the value of x, okay, and you got the value as, let's say, some 0.0002, for example. Okay. Now, with this value, since this is less than 0.05, in this scenario, you are going to reject the, what you're going to do, you are going to reject this and accept this. Agree? As per your hypothesis, you are doing perfect thing. Okay, but later when you have plotted this x value and if you observe the graph, that is a normal distribution. Okay, that is actually a normal distribution. But what you have done, you have considered the alternate hypothesis, which is saying not a normal. You have done a mistake. What mistake you have done? The null hypothesis, which is saying it is normal distribution, you have rejected that. So that means you have rejected a true null hypothesis. Are you getting?
Yes, sir.
Okay, so that comes on the type 1 error.
Yes, sir.
Okay, that comes under a type 1 error. Okay, so if you remember over here, so what is type 1 error? You reject a true null hypothesis. Okay, I'm just giving you a scenario. Okay, but if you're getting confused, that's fine. So you can forget about that. But just if you stick to the Shapiro test, so passing the value of x, right? So by p-value only you can consider whether that is a normal distribution or not. Okay, fine. So now let's say you have the y value. Okay, so I'm creating one more data set called as np.random.uniform. Okay, I'm creating a uniform distribution. Okay, so over here, so now if I plot y, okay, so this is a diagram, okay, y, and if I try to plot y, okay, so can you see it is almost same uniform kind of distribution. Okay, now if I pass the value of y, so can you see what I'm getting? Can you see what I'm getting? What is this value, guys? This is not 3.16. It is, you should observe the last part. It is e to the power of -0.07. That means what? 3.16 whatever you are having by 10 to the power of 7. That means it is actually 1, 2, 3, 4, 5, 6, 7, 0 point. Okay, like 0.603, 4, 5, 6 and 3169. Okay, this value is that. Getting?
Yes, sir.
Okay, so now this value, okay, this value is p. So in this case, what? P is greater than or less than alpha?
Less than alpha.
Less than alpha. So what we need to do?
Reject null hypothesis. Reject the null
Reject null
hypothesis.
hypothesis. And what does null hypothesis saying? Null hypothesis says it is normal distributed. Alternate will say it is not normal distributed. Not normal distributed. So in this case, because of the p-value is less than alpha, that means you are having less area, small area, moving away from null hypothesis, you are going to reject this guy and accept this guy. So accepting this guy means it is not a normal distribution, and that is also true with our diagram. So this is not a normal distribution. Why? This is a uniform distribution. Okay, is it clear?
Yes, sir.
Okay, cool. So that is one way how you can use the p-value, guys. Okay, so now coming to next concept. Okay, now coming to next concept, we have something called as t-test. Okay, we have something called as t-test, guys. So now we have seen z-test. Okay, in the hypothesis scenario, sorry, in the hypothesis testing, till now we have seen the z-test. Okay, even in this example also, the company training example, so you are considering the z-test from z, that's why you're using the z statistic, x bar minus mu by all this. Okay, even in the next, I think the wafer example also, where was that? Yeah, even in the lace wafer example also, you're using the z statistic. Okay, but there is one more test called as t-test, guys. Okay, so when this will come into picture means, yeah, so when you don't have, okay, when you don't have population standard deviation, okay, so when you don't have population standard deviation, okay, so and when the sample size is small, okay, when small sample, okay, and when you have small sample and when you don't have the population standard deviation, okay, in that scenario we need to go for the t-test case. And what you know, in real life, most of the time this is a test we will consider, because most of the time we don't have the population standard deviation. Okay, we don't have population parameters most of the time. Because why? Because population is very huge data, obviously we don't have parameters for that. Okay, so if you see here, a t-test is a statistical test used in hypothesis testing to compare the means of two samples, or to compare a sample mean to a known population mean. Okay, and different scenarios. Okay, when the population standard deviation is unknown, okay, and the sample size is small. Okay, mainly when you have a small sample. What do you mean by small sample here? When the sample size is less than 30, usually. Okay, usually if the sample size is greater than 30, you can go for z-test. But small sample, okay, that means if the sample size is less than 30, like 25, 24, 15, some samples, so then you need to go for the t-test. Okay, so there are mainly three type of t-test, guys. Okay, so it's called one sample t-test, okay, and independent two sample t-test, okay, and paired t-test, okay, dependent tools to sample t-test, okay. So all this is simple, okay. So I'll just give a brief about each of these. One sample t-test means, see, the one sample t-test is to compare the mean of a single sample to a known population, okay. So that means what, you have a population, okay, and it is having some mean. What is that mu? From that you took a sample, okay. So this is population, this is sample, and what is the mean of this? Okay, this will be x bar. Okay, so now we want to compare whether this x bar is equal to mu or not. Okay, so it is used to compare the single sample to a known population mean. Sorry, mean of a single sample to a population mean. Okay, this is one type of t-test. Okay, but remember, any test we are speaking, fundamentally that is an hypothesis test. Okay, any test we speak is fundamentally a hypothesis testing. Okay, so the moment when you say hypothesis testing, obviously it should have two hypotheses, null hypothesis and alternate hypothesis. Okay, so that is applicable everywhere. So here also in this one sample t-test, when you compare a sample mean, whether it is equal to a population mean or not, okay, so in this scenario what happens, the null hypothesis states that there is no significant difference. No, sorry, there is no significant difference between sample mean, population mean. Okay, so what does this null hypothesis will say? So it says that the population mean is equal to sample mean. Okay, there is no significant difference is what that is saying. Fine. So while the alternate hypothesis states that there is significant, okay, but alternate says there is significant difference. That means both are not equal. Getting guys, what does one sample t-test mean?
Yes, sir.
Everybody, okay?
Sir, can you repeat again?
Sure. See, fundamentally t-test is when you consider when the sample size is small or population standard deviation unknown. Okay, so it's a more practical case. That means small sample, population standard deviation is not known, then only you will consider here. Okay, so because if you go for the z-test, Meghana, so if you see here in the z-test what we are doing, so yeah, so in the z-test, what is this x bar minus mu? Okay, so x bar minus mu by rho by square root of n. Okay, so now here what is this rho? Rho is the population standard deviation. Agree? Rho is the population standard deviation. Fine, and the sample size is also high. That means what? Greater than or equal to 30. Okay, see here it is, he's taking at least 30 samples. Okay, so in this scenario, in the previous example, we can use a z-test. Okay, sample size is decent samples, and also you know the population standard deviation. Okay, why? Because can you see here, he's only saying the population standard deviation is 5 units. Okay, so when you have the population standard deviation and the sample size is greater than 30 or equal to 30, you can go for the z-test. Do you agree?
Yes, sir.
But usually practical scenario, most of the time we will not have the population standard deviation. Okay, and the sample size will also be not equal to 30. Okay, so in that scenarios, okay, you need to go for a what? T-test. Okay, and in the other example also, in the lace wafer example also, see, we got the population standard deviation. See, population standard deviation is saying is 4, and how many samples we took? He took a sample of 40. Okay, so obviously sample size is more, that means greater than 30, and also population standard deviation is also known. So obviously we can use the z-test. But if at all you don't have these two, that means what? So if your population standard deviation is not known and also sample size is small, you should go for the t-test. Okay, that is first point when t-test will come into picture. Now inside that you have mainly 3 types of test. One is one sample t-test, okay, and remaining are these two. First of all, the one sample t-test means what? It will test that it will compare 2 things. What is that? So one is the population mean and one is a sample mean. Okay, that means let's say you are having a population, its mean is mu. Then you are having a sample, you took a sample from it. Okay, its mean will be x bar. Okay, now if you want to compare these two are equal or not, okay, if you want to compare these two are equal or not, okay, then that is called as one sample t-test. That means you are comparing one value Okay, you're just comparing one value. It's not like you're having two types of data sets and you're comparing whether the means of these two are equal or not. Okay, from the single data set only, you are taking a sample, okay, sub data set, sample data set, and you are comparing whether this sample mean is equal to population mean or not. Okay, it's the only one sample. Okay, only one sample you are taking. If you take two samples like this, okay, let's say from population you are taking one sample, that's called S1, and if you take one more sample, that's called S2, and you are checking the means of those two, then that is two sample t-test. Okay, we'll check that. Okay, but as of now, only one sample. You take only one sample and check if that sample mean is equal to the population mean or not. Is it clear?
Yes, sir. Clear.
Okay, now fundamentally you should not forget that whatever we are doing over here, that is ultimately called as hypothesis testing. Okay, so whether it is t-test or whether it is a z-test or whether it is, in tomorrow's class we will studying something called as chi-square test, chi-square test, or ANOVA test, all these are hypothesis testing, okay, under the same umbrella. Now what is hypothesis testing? Simple. You consider null, you consider alternate, and do some testing, get some z statistic or t statistic and some p-value, and you see whether you are having sufficient evidence for the accepting or rejecting the null hypothesis. That funda will be same, what irrespective of the test. Okay, so same thing here also. In one sample t-test also you will have both alternate and null. What does null say over here? Null say there is no significant difference between sample mean and population mean. Okay, so there is no significant difference between population. So population mean is mu and x bar is a sample. So null will say both are same. Alternate is saying no, both are different. Okay, which is true, we don't know. We should do some test and find out. Okay, but these are the hypothesis testing statements. Is it clear, everyone?
Yes, sir.
Yes. Okay. Karthik, Sirisha, is it someone saying? Yes. Oh, yes, Karthik. Okay. So now, yeah. So now, if you see, I'm saying scores of, yeah, I'll show different examples. Okay, then you can understand it in a better way. Okay, so we'll see. Yeah. Suppose a, yeah, so let's see. Suppose a manufacturer claims that the average weight of their new chocolate bar is 50 grams. Okay, what he's saying, a new chocolate manufacturer saying he has manufactured new chocolate bar and his weight is, new chocolate weight is 50 grams. We highly doubt that and we want to check this. So we draw a sample of 25 and measure their weight. The sample comes out to be 49.7. Okay, and the sample standard deviation is 1.2. Consider the significance level of 0.05. See guys, now what's happening over here is you should observe 3 to 4 things. Okay, first thing is, okay, just a second, let me 1 second. Yeah guys, so here you need to observe carefully few things, what he's saying. So he's saying initially the average weight is 50. Okay, so but we doubt that whatever statement is passing, we doubt it, so we want to do some testing. So for the testing, what samples we have, how many samples we have considered? 25. And you should notice that this is less than 30. Okay, so samples n is less than 30. So that is the first indication that indirectly he's saying to use a t-test. And second thing is, he's saying the sample standard deviation is 1.2, not the population. In the previous example, if you see in the wafers example, here he's saying the population standard deviation is 4 grams. Okay, but in t-test will be used, just now we have discussed that when you don't know the population. Okay, so in that scenario, you will have the sample standard deviation. So here sample standard deviation is 1.2. Okay, and the significance level is 0.05. Fine. So now if you see here, what all we have. So you have, okay, the population mean is 50. Agree? Population mean, the actual, the manufacturer is saying the new chocolate bar is 50 grams, population mean. What is the sample size, guys? N equal to 25. Okay, N equal 25 sample size. And what is the sample mean? Sample mean is 49.7. Okay. And what is alpha? Alpha is 0.05 level of significance. Okay. And what is sample standard deviation? 1.2. Okay. These are the details he has provided us. Using that, what he is saying, we need to test whether he's saying that the new chocolate, okay, new chocolate bar, okay, new chocolate bar, okay, he's saying that his weight is 50 grams. Okay, this weight is 50 grams. He is making a statement. Okay, so for that I've considered 25 chocolate bars and I am just calculating the weight. I got 47, but whether this sample, whatever the weight I got from the sample, 49.7. Okay, so whether this is correct or not, I mean, from this sample, can I just declare that whatever statement he's saying that is false, and or I cannot reject that statement? Okay, it could be two ways. Okay, because see, just from 25 chocolates, if I pick up and if I just try to disprove his statement, that is also not fair, right? Because population will be a huge population. Okay, like thousands of chocolates. From that, I'm just taking 25 chocolates because that much quantity is only available. Okay, sometimes we don't have much samples for testing. Okay, the manufacturer has provided us with only a small 25 chocolate bars. From that, if I calculate and if I have certain mean, that is 49.7, now we need to test whether how much confidently we can say from our small sample testing that whatever statement he is making is true or false. Okay, so that thing we need to decide. So over here again, null hypothesis, what does null hypothesis will say? Null hypothesis will say, okay, it will say that the mean is 50. Okay, and alternate hypothesis will say mean is not equal to 50. Mean is not equal to 50. Okay, fine. So now let's try to do some testing. Okay, so first of all we need to calculate the t statistic. Okay, earlier when you are calculating this one, so we calculated something called as z statistic. Agree? Z statistic. Okay, similarly, because that is a z test, similarly now for the t test we need to consider something called as t statistic, guys. Okay, t statistic. It is simple. So it's called the formula is x bar minus mu by s by square root of n. Okay, now what is just what is the difference here? It will be x bar minus mu by rho by square root of n, because rho is the population standard deviation. Okay, but here you don't know the rho, that means population standard deviation is not available. In that place you have the sample standard deviation 1.2. Okay, that's the only difference, and the sample size is also small. Now what is x bar? X bar is 49.7. okay, minus what? 50. Mu is 50 by what is s? S is 1.2. okay, by square root of what is n? N is 25. Okay, now can someone do the calculation and help me? Let me see. What is this? 49.7 minus 50 is minus 0.3. Okay, minus 0.3 by how much will be this, guys? Square root of 25 will be 5, right? And this is 1.2 divided by 5 is 0.24. Okay, this is 0.24. And now what will be this? 0.3 by 0.24. 1.25 minus 1.25. Agree? Okay, so now going back, what do we have? We have the graph. Okay, this is our graph, and now we have two edges. So now can someone tell me whether this is a one tail test or two tail test?
Two tail test.
Why?
View is population will not equal to 50 means it should be less than or greater than.
Perfect, superb. Okay, so it is not, when he's saying not equal, that means could be greater than or less than. He's not asking only less than or greater than. Okay, so in that scenario, it is a two tail test. Awesome. Okay, so now I will also mention here it is a two tail test. Okay, so now over here, so what was our value? Our t statistic is minus 1.25. So that means we'll have put it over here. So our t statistic is 1.25 will be over here, and here also it will be minus 1.25. Okay, so now you need to calculate the area. Okay, so how much area it is covering. Okay, t statistic is what? T statistic is giving you the value over here. So if I just try to correlate with the previous example, so over here if you see, we got the value as 1.58. Okay, so from where did you get this 1.58? Okay, so you have calculated the t statistic. Okay, so yeah, for example, if you see here, z statistic is 3.28. Okay, this is 3.28, and how much area it is covering is the p value. Okay, so similarly over here also, if you see, our t statistics is minus 1.25. Okay, so it's minus 1.25 and plus 1.25, the two tail test. And now you need to see how much area does this covering. Okay, this area. Okay, this area is how much. Okay, so for that actually in t-test you have a easier way. Okay, so for example, if you see over here, you have directly called as CDF. Okay, so Srisha is asking, sir, root ni enduku consider cheyyaru. Okay, consider, what was that? Cheyyali sir, root, which root? Which root? This root? S by root n. That is a formula, right? For sample. So if you see, that is a formula, right, Sirisha? Over here, if you see central limit theorem, if you go back to central limit theorem, Sirisha, apun manam check chesam kada. If population mu and rho square unte, sample emuntadi mu by rho square by n. Okay, what is this? This is variance. Okay, so this is variance. So manaki standard deviation kavalante, you need to apply root. Now this will become rho by square root of n. Okay, so similarly here also, that is the reason you need to go for the, but here in the place of rho you will have s. Okay, s by square root of n. It's from the central limit theorem. Okay, so now going back to, yeah, so over here, yeah, so you have now our job is to find out how much area it is occupying over here at a t statistic value of minus 1.25. Okay, so when you have minus 1.25, how much area is occupied? Okay, so for that you can have it called CDF actually. So this is called CDF. If you remember, if you consider a value and how much area is covering below, less than or equal to that value, is called a CDF. Okay, so to calculate CDF, you can directly use something called as from scipy.stats import t. Okay, and t.cdf. Okay, t.cdf can give you the value. Okay, and you need to pass two values. Okay, one is a t value or t statistic, and also the degree of freedom. So if you remember, we discussed degree of freedom when we are discussing the t-test. Okay, so if I just go and make you recollect that, see here. So in the t distribution, okay, you have degrees of freedom. Okay, what is degrees of freedom? It's just number of samples minus 1. Remember? So as the number of samples keep on increasing, it will try to become more and more similar to the normal distribution or standard normal distribution. The sample size are continuously decreasing, it will move away from the normal distribution. Okay, so whenever you are using t distribution, okay, t-test, degrees of freedom will come into picture. Fine. So over here also, now what we want the area that is covered by 1.25. Okay, for that you can directly use something called as scipy.stats import t. Okay, t.cdf. Okay, there you need to pass two values. One is t statistic and degrees of freedom. What is our t statistic? Minus 1.25. Agree? And what is the number of samples? Number of samples is 25. Okay, so this is minus 1.25 and number of samples minus 1 will be the degrees of freedom 24. Okay, fine. So once you pass that, what are the value you are getting? Okay, so I'm doing into 2. Okay, I am doing into 2. Why I'm doing into 2? So each side I want this side you will have one area A1, this side you will have one more area A2. Okay, so but if you want only one value, so you can just calculate the CDF value. Okay, it is 0.11. Okay, is this clear, guys? Just pass your t statistic value and df value, degrees of freedom, and t.cdf. You pass this value, you get the CDF value. Okay, that is the area. That means what? Wherever you are having minus 1.25, the less than or equal to this value, this much area is occupied. Okay, that means you're having minus 1.25, this much area is occupied. Okay, similarly here also 1.25, this side it will be 1.25. Okay, so how much is the area? 0.11. Okay, so this is 0.11. Oh, sorry. Okay, so this is 0.11 and this is also 0.11. So total area will be, p value will be what? P value will be A1 plus A2 total area. That will be equal to 2 into 0.11, which is equal to 0.22. Okay, that is equal to 0.22. Okay, so now p value is 0.22. So now what is the relationship now? Again, now if I go back, so now we have the p value, which is 0.22. Okay, so I think Sirisha was having network issue. See, Sirisha, I will repeat 1 minute back. See, we have calculated using the t statistic, we have calculated the CDF value. Okay, that means how much area is occupied for the value less than or equal to minus 1.25. It is 0.11. Okay, so that means 0.11 will be over here and also here also 0.11. So combined area, because you are doing two tail test, it will be A1 plus A2, 2 times 0.11, 0.22. Okay, now p value is 0.22 and alpha is 0.05. Okay, now what is the relationship, guys? P is less than or greater than alpha. P is greater than alpha. So in this case, what can we do? Reject or accept? If P is greater than alpha, what we should do, guys?
Accept.
Accept. Okay, accept the null hypothesis. Okay, so we are going to accept null hypothesis. And what is the null hypothesis saying? Null hypothesis is saying mean is 50. Okay, so whatever he is claiming, okay, that we can accept it. Okay, that means what? Just from the sample, okay, ఒక చిన్న sample 25 count sample తీసుకొని మనం sample mean 49.7 వస్తే దాంతోని మనం చెప్పలేము ఓవరాల్ పాపులేషన్ కూడా 49.7 ఉంటది అని చెప్పి, ఎందుకంటే that will be loss for him. Okay, so using the t-test we have calculated and we have seen the evidence whether we can calculate sufficient evidence, but we are not able to find out the evidence to support to reject the null hypothesis. Okay, in this scenario we need to accept the null hypothesis. And what is null hypothesis saying? Mean equal to 50. Yes, so we can say, yeah, whatever he is claiming, the new bar, chocolate bar weight is 50 grams only. Okay, that is how you can conduct the t-test. Everything will be same. So here in the here it was lace, here it is chocolate, that's it. only difference is you use a t-test. In t-test, what new things you will find? One is the, in place of standard population standard deviation, you will have the sample standard deviation. Okay, and in place of and also here you should use something called as degrees of freedom, okay, to get the CDF value. Okay, so for the z-test you have used the z tables. Okay, so for t-test you can also use a t-table, but this is a easier way. Okay, so during when I was discussing the t-test, okay, I show you the t-tables, right? So you can use that, but the best way is if you have directly have the t-statistic. Okay, see, calculating t-statistics super easy. Agree? So what is it? Just use this formula, substitute the values, you get the t-statistic. Okay, give the t-statistic value, put the degrees of freedom, number of samples minus 1. You will get the value. That's it. If it is one sample t-test, you can directly use this value. Sorry, it is one tail test, directly use this value. If it is two tail test, you do multiply into 2, so that you will have the overall area. And then you just compare it with the alpha value. Okay, because he's only saying significance level of 0.05. Compare it with that. If it is greater than alpha, accept. If it is less than alpha, reject null hypothesis. Simple. Is this clear, guys? Everybody? Any doubts? Anybody? Sir, how we got 0.111 still, sir, Sirisha? Okay, see, Sirisha. See, Sirisha, did you understand like how did we get minus 1.25?
Yes.
Okay. So now what is 1.25? Where is 1.25? Over here. Okay, this particular mark. Okay, this particular mark on the graph is 1.25. Now I want to know what is p-value at the end of the day. It's an area. So I want to know how much area is covered till 1.25 or minus 1.25. That means what? This area. Okay, this area I want. To find out this, you can simply use this code. Okay, what is this area? This is called CDF. If you remember, in the initial class of statistics, I was discussing in detail what is CDF, cumulative distribution population probability. Okay, that means what? If you give a particular value, how much area is covered less than or equal to that value. Okay, this area is area, okay, of where the value x is less than or equal to minus 1.25. Okay, less than or equal to minus 1.25. Okay, to find out that, you can simply use this in from scipy.stats import t. Okay, in the t you will have something called as CDF. Okay, so t.cdf, for this t.cdf, okay, module, you need to pass two values. What is that? One is t statistics and one is degrees of freedom. What is t statistic? You calculated t statistic with this formula, you got minus 1.25. Okay, give that value minus 1.25, and degrees of freedom is what? Number of samples minus 1. Our number of samples is 25, minus 1 is 24. Okay, these two values you give it over here, and whatever the value you are going to get, it is a CDF value. That means 0.11. What is this 0.11? That is the area. The area covered till minus 1.25. Here also, this area will also be what? 0.11, because you are finding greater than 1.25. Okay, this area will also be 0.11. So 0.11, 0.11 total, it will be 0.22. That is p-value.
Yes, sir, understood.
Okay, cool. So this is how you can perform t-test, guys. Okay, so one sample t-test you can say. Now there is also one more example I would like to show you using the t-test. Okay, so for example, if you see here, yeah, so for example, if you see here, there is data set auto MPG. Okay, so over here, when I read this, these are the columns it is having. Okay, and there is, if I take horsepower. Okay, so horsepower, if I plot it, obviously this is not a normal distribution. Correct, it is not at all a normal distribution. So now if I check it, if I just pass it to Shapiro. Okay, so if I pass to what is it? Okay, let me just. Okay, horsepower, that column might be having some issue. Let me try with some. Yeah. So displacement, if you see displacement, okay. So what is the value of p-value, guys? If you see the p-value, it is how much? Is it 4.46?
No, sir.
No, it is
By
8 to the power of minus 17. That means what? Extremely less than, closer to 0. That means after 0, after 0 dot, you need to use 17 zeros. That means 0, 0, 0, 0, 0, 0, 0, 4, 4, 6. Okay, this is very, very almost equal to 0. Okay, and our alpha will be 0.05. Agree? And now this is p-value. Now, if p-value is less than alpha, yes, p-value is very much less than the alpha. So in this case, we need to accept or reject null hypothesis.
reject.
Reject null hypothesis. Okay, and null hypothesis usually say that the distribution is normal distribution, right? Alternate will say it is not a normal distribution. So now in our scenario where we need to reject null hypothesis, that means this is not a normal distribution. It is, yeah, normal distribution, whatever the null hypothesis is saying, that we are rejecting, and it is not a normal distribution. Alternate hypothesis we need to accept, and it is also true, because if you see here, this is clearly, it's almost like a uniform distribution. There is no normal distribution at all. Okay, so any data set, usually any data set, okay, in future you'll be working on different types of data set. If you have doubt whether it is a normal distribution or not, you just take that data set and pass it to Shapiro. And if you remember, the other way of testing the normality is QQ plot. You remember the name? We discussed something called as QQ plot, quantile plot. So using that also you can find out, do the normality test, okay, whether the given distribution is a normal distribution or not. This is statistical. This is one more way how you can, okay, check. Fine. Okay, so now yeah, coming to few more examples over here. So over here, if you see, let's say these are different cricket matches, okay, and these are the scores. Okay, these are my scores and these are Virat Kohli scores. Okay, just as an example. And how many matches did we play? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 10 matches I have played, and 10 matches here I have played, and you can see. So these are the different scores in each match. Now if I see, if I do one sample t-test, okay, that means only one sample test I'm doing. Okay, so over here, what I'm saying, my score, okay, so see here, observe here. Yeah, so what is my score? Okay, so let's say Santosh. Okay, so Santosh score is 23.5. Fine, so this is my score. Now if I am checking, okay, see scipy.stats.t-test one sample. Okay, from scipy only you have something called as scipy.stats t-test one sample. Okay, so over here, if you pass my score, okay, what is my score? My score is this. Okay, my score. And if I check that whether that mean is equal to 24.5 or not. Okay, guys, I am asking whether the mean of this my score is equal to 24.5 or not. Okay, so actually score is 23.5. Getting? I am checking whether it is equal to 24.5 or not. Okay, so now if you see here, okay, so first of all, let me show you whether I'm checking whether that is equal to 10. Okay, see guys, how much value I'm getting. See here also, you will have two things. One is null. Okay, what it will say? Yes, scores are equal. Okay, scores are equal. Alternate will say not equal. Okay, so if you see my score and 10, I'm checking whether the mean of this my score, this value is equal to 10 or not. Obviously it's not, right? So why? Because this score is 23.5 and this is 10. Now if you're comparing these two, the value of p you can see is e to the power of 0.5. That means 0.00, very much less. So in that case, I should reject the null hypothesis. Agree? So reject null hypothesis means I will say accept this guy and say whatever you are comparing are not equal. Okay, that means the mean of this is not equal to 10. That's what this guy is saying. Are you getting? Or shall I repeat?
Understood, sir.
Understood? Okay. So now if you as I change this value, observe the p-value. So if I come closer to this value, okay. So for example, I'm coming to 15, okay. So as you can see, it is somewhat greater than previous value. It's 0.0006. Still it is less than 0.05. Okay. See what is our alpha? Alpha is 0.05. Okay. Still it is less than 0.05. So I'm going to reject it. Okay. I'm going to reject this null hypothesis and accept the alternate and say both are not equal. Okay. But still it is better because earlier when I have 10, it is very much less. Okay. But now it is at least somewhat better. Okay. Now when I go to 20, okay. So it is somewhat better. Okay. So it is saying 0.06. Okay. Now 0.06 is greater than 0.05. Okay. So in this case, I can accept the null hypothesis. Okay. So yeah, both are not equal, but at least it is almost closer by. Okay. So when I go to still more 22, if I go to 22, you can see it is much better, 0.3. Okay. And if I go for 23.5 exactly, you will have 1. Okay. P-value is 1. That means maximum probability you are having. What is 1? 1 is, what is p-value? You can clearly understand from here what is p-value at the end of the day. It is just the probability of null hypothesis being true. Okay. So in this scenario also, you are having 1 means maximum probability you are having. That means null hypothesis is perfectly true. What is null hypothesis? Scores are equal. And is it equal? Yes. The actual score is 23.5. I'm comparing 23.5. So you can happily approve this guy. What is saying, sir? Am I unable to see the screen? Hey, can everybody see the screen? Sirisha is not able to see the screen. Others, can you confirm?
Yes, sir, I can see.
Oh, okay. Sirisha, try rejoining. Others can see. Now, okay, okay, fine. Okay, so see guys. So when I'm comparing with the exact value, you are having the maximum probability. Okay, so here when you're having 1, that means he's saying accept the null hypothesis, scores are equal. Okay, but if I start moving away, okay, so if I go to 25, the p-value is 0.3. Okay, still it is greater than alpha, I can accept. But if I keep on increasing, let's say 30, see it is 0.03, 0.03, which is less than alpha. Okay, this is less than alpha, so I should reject null hypothesis and say alternate. That means both are not equal. Okay, so if I keep on increasing like 33, this will keep on increasing. Okay, so if I go to 40, okay, see it has again went into e to the power of -6. If I keep on increasing, it will see e to the power of -12. Now if I keep on coming towards value 24, if I go, it is 0.07. okay, that means greater than alpha, I can accept. Okay, again if I go to this side like 19 for example, it is 0.02. okay, less than alpha, I will reject it. Okay, so that's how you can play with the values and see whether both are equal or not. Okay, whether the mean is equal to the given value or not. Okay, that is also comes under one sample t-test. Is this clear, guys?
Yes, sir.
Okay, cool. So now if I show you, yeah, so that is regarding one sample. Now if I go for the second independent 2 sample t-test, okay, so here what is happening, the independent 2 sample t-test is used to compare means of 2 independent samples. Okay, 2 independent samples. Earlier it was only 1 sample, but here we can compare means of 2 independent samples. The null hypothesis states that there is no significant difference. Alternate will say there is significant. Null and alternate almost will be same, guys. Here even in 1 sample or 2 sample also, or in paired t-test, any test, normally null will assume that there is no interest, nothing interesting is happening, or there is no change, there is no relationship. Okay, there is no correlation, etc. Okay, it will be in some of these scenarios. Okay, so here also in this scenario also, the null will say there is no significant difference between the 2 samples. That means both the samples are equal. Okay, that means sample 1 is equal to sample 2 mean. Sample 1 mean is equal to sample 2 mean, that is a null. And alternate will say no, there is some difference. That means first sample mean is not equal to second sample mean. Okay, so now since we are considering 2 independent samples, okay, 2 independent samples, so that's why it's called independent 2 sample t-test. Both these are independent samples. Okay, from population only you took sample 1. Okay, and separately you took one more sample 2. Okay, so these 2 sample means you are comparing. That's why it's called independent 2 sample t-test. Okay, so for example over here, if you see, yeah, so in this scenario, if you see, these are two different samples, okay, my score and Virat score. Okay, so in this scenario, if I pass to t-test independent, okay, so in this t-test independent, earlier it was t-test one sample, okay, but now if you use t-test independent sample test, okay, over here what I'm using my score and Virat score, okay, these two are scores, and if I pass that, okay, now what is the mean of my score? 23.5 and his score is 47.4. Okay, so are they equal? No, obviously they're not equal. Okay, so what is here also? Okay, if I just quickly write, okay, null will say sample one, okay, score 1 is equal to score 2, null will say, okay, and alternate will say score 1 is not equal to score 2. That's what alternate job. And now we got the p-value is where is this? You need to use stats.t-test independent samples. Okay, you need to go for the p-value. It is very much less. You see e to the power of 0.06, it is very much less, and our alpha is 0.05. Okay, so in this scenario, p-value is less than alpha. Okay, so we need to reject the null hypothesis. Okay, this guy is rejected and this guy is accepted. So that means scores are not equal. Obviously, the scores are not equal. Is it clear?
Yes, sir.
Okay. So, but if I let's say if everybody is scolding me and I want to improve my score, okay, so for example, I'll try to copy this, okay, and but I'm not that great as Virat, okay, so let me say I scored only 43 somewhat nearby, and this is 40 and this is 60 and this is 38, 36 over here, 72, okay, 50, 42, 40, 40. Okay, now for example, this is my score, okay, and now if I compare, as you can see, it is 0.7. Okay, so in this scenario, my new score is p-value is 0.7, okay, which is greater than 0.05. That means alpha. So p is greater than alpha. So if p-value is greater than alpha, area is more, okay, and the value is more. So in that scenario, we will accept the null hypothesis and reject the alternate. Agree? So what is null hypothesis saying? Scores are equal. So here the scores are almost equal. It's not exactly equal, but that is fine. Okay. So according to p-value, you can consider these both the scores are almost equal. Okay, because you are having good value of p greater than the alpha. That is, you are considering two different samples. Okay, earlier you are comparing only one sample and with a particular value. Okay, whether the mean is equal to this value or not. But now you are taking two independent samples and checking the mean of these two samples are equal or not. For that, you need to use t-test independent sample. But the p-value, the concept and the logic is same. Consider p-value, consider the alpha, check less than, greater than, reject or accept. Is it clear? Are you getting this really?
Yes, sir.
Okay, great. Okay, so that is regarding the two sample t-test. Now, if you go to the last one, okay, so over here, you have something called as, what do we have? Okay, yeah, so over here you have paid t-test case. Okay, so this is also two sample t-test only, but it is a dependent sample. That means what? Same sample, first you will calculate something, and let's say you have done some changes or you took some action, and after that on the same sample you will find out the mean and you will see whether there is any difference or not. Okay, let's try to understand. The paid t-test is used to compare the means of two samples that are dependent or paid. Okay, so if there is some dependency between two samples, okay, then you can go for the paid dependent two sample t-test, such as pre-test and post-test. Okay, pre-test, post-test. That means what? Usually you have your measurements, right? So let's say your blood pressure, okay, for example, eyesight, BP, sugar, cholesterol, and heart, all these measurements you have considered pre-test. That means before eating, pre-lunch and post-lunch. Okay, normally sugar test we'll do, right? So in that scenario, the same set of values, but before test and after test. Okay, so if you have those scores, okay, for the same group of subjects or measurements taken on the same subjects under two different conditions, okay, that means what? Before eating and after eating, before lunch and after lunch, okay, same test of same measurements if you consider. In those scenarios, you need to go for the paid two sample t-test, that is paid t-test. Okay, so over there also the null hypothesis states that there is no significant difference. Same thing, null will always say there is no significant difference. That means it will say, null will say what? Null will say pre equal to post. Agree? Alternate will say pre not equal to post. Clear? Okay, so in that scenario, we need to go for the paid t-test. Now, if I just show you an example, yeah, so over here, if I have my score is this, okay, and my score second tour, okay, same score before and after, okay, let's say I scored this much, and later that my coach criticized me, okay, I felt very bad, and then I improved my performance, and this is my score in the second tour. Okay, so in that scenario, you need to use something called as t-test relative, REL relative. That means what? These are not different samples, these are the same samples, dependent samples, but at different timestamps. Okay, like you have pre-test and post-test. This is like pre motivation class or post motivation class. Okay, so someone gave me motivation, and after that I started playing well. Okay, so it is pre and post scores of myself only. Okay, so in that scenario, you need to go for the SkyPay.stats t-test relative. Okay, so if they're independent, you need to go for IND. If they're relative, the dependent there, then you need to go for the REL. Okay, so in that scenario also you can use this value, and as you can see, the difference is very much big. That means these scores are very less, this is high, so obviously the value is less. Okay, so this p-value is less than alpha, so I need to reject the null hypothesis. That means alternate, what does alternate say? The scores are not equal, S1 not equal to S2. That is true, because the scores are different. Okay, but just for example, if I just copy this and just if I paste over here, and if I run this, you can see p-value is none. Okay, so let me change some values. Okay, yeah, so you have, it's a way, if the scores are very exactly similar to my score, so obviously you have very good p-value, which is 0.3. okay, which is greater than, in this scenario, p is greater than alpha. That means you need to accept the null hypothesis. What does null hypothesis say? Score 1 equal to score 2. That means before and after the event, the scores are same, and you can see it is almost same. Okay, same scenario, but it is relative test, and earlier it is an independent test. This is one sample test. Okay, so that is regarding the t-test. And for this relative, right, so I will show you one more example. Okay, so for example, if you see here, guys, okay, so if you see here the same scenario, and see np.array, so I'm taking one data set. Okay, before, okay, these are some measurements. Okay, and after that, okay, and after that, so first of all, let me show you this. Okay, this is before, this is after. Okay, so this is before and this is after, and if you see the difference, okay, so the difference is almost small. Okay, very small. Okay, so and null hypothesis will say there is no difference, and alternate will say there is some difference. Okay, same thing which we are seeing. Okay, and if you directly, what you can do here is you can pass the Shapiro, you can pass the differences to the Shapiro, stats.Shapiro. Okay, and based upon the Shapiro value, okay, see here the Shapiro value is 0.02. okay, 0.02 means what? It is greater than alpha. Agree? So 0.02 is greater than, sorry, not 0.02, 0.2. okay, 0.2 p value, p of 0.2, sorry, is greater than alpha of 0.05. okay, in this case, accept or reject? Accept or reject?
Accept.
Okay, yeah, so in this case we need to accept the null hypothesis. Okay, and what is null hypothesis saying? Let me go back. Okay, null hypothesis saying there is no significant difference. Okay, so obviously there is no significant difference, these are all small differences. Okay, 78, 80, 92, 93, all very closer to each other. Okay, so the before and after the value says also it is not much significant difference, that we are going to accept. How you can pass the values to the Shapiro directly, and also you can get the from the p-value also you can try to find out. But let's say if I have some very significantly different data set, okay, this is my after values. Okay, now if you see the difference is extremely high. Okay, so in that scenario, okay, if I draw a graph, okay, you can see the p-value is 0.01. okay, the p-value is 0.01. okay, a p-value of 0.01, okay, so is obviously less than alpha of 0.05. okay, so if it is less than, obviously it is moving away from the null hypothesis, small area, so you need to reject the null hypothesis. okay, so when you're rejecting the null hypothesis, what is null hypothesis saying? No significant difference. This we are rejecting and accepting what alternates, some significant difference. okay, so obviously there is some significant difference. okay, so in that, using this also you can calculate whether two dependent values are having any difference or not before and after the some event. okay, so this is how you can use the value of p. okay, is it clear, guys? Any doubts, questions, queries? okay, cool. So this is regarding the t-test, guys, actually. okay, so I hope that you are comfortable to some extent how to understand p-values, how to use, and how to decide whether accept or reject null hypothesis, right? So at least I hope you are 70 to 80% comfortable. okay, as we have seen different examples. okay, so remember p-value is not related to one single test. okay, that is a general topic. You can use it to z-test, you can use it to what, you can use it to t-test. okay, and you can use it to Shapiro test. okay, different types of tests you can clearly use it and find out the and find out what to reject or accept null hypothesis. okay, it is not only related to normal distribution. okay, so it is just p-value is just telling whether you can accept or reject null hypothesis. Now null hypothesis could be anything. In our scenario, you can take it as normal distributed, or mean is equal to sample mean, or there is some correlation existing. Anything you can take. okay, so p-value will just tell you whether you can accept or reject. okay, fine. So that's all regarding the t-test, guys. okay, and I would say we have covered almost all the required concepts of stats. There are only two pending concepts actually over there. So one thing is called as chi-square test. okay, there are two tests. One is called as chi-square test. okay, and second thing is called as ANOVA. okay, which is called analysis of variance. okay, and one is chi-square test. okay, and if you remember chi-square test, okay, so somewhere in our first class or second class we have discussed, I think. Yeah, so this contingency table, whatever you are seeing, right, so that is related to chi-square test actually. okay, bivariate analysis. okay, that we will see anyhow. okay, so but important point here is we have reached to the almost end of the stats module, guys. okay, so I'm happy we are able to cover all the required concepts. okay, even though it was a bit delayed, but I am really happy I was able to cover all the required details. okay, and also try to share this notebook also, this one notebook, so where you have all the each class related discussion notes available over here. okay, so you can go through that. Fine. And yeah, so even after this also you can pose me any questions regarding the stats. okay, but however, I'm planning to, okay, so just a second, guys, let me stop the recording and I have few things to discuss. okay, before that, any doubts, guys, regarding till here, till t-test, or are we good?